Welcome. Today, we are looking at wave properties. This is topic 10 in your SS2 physics series. This is the final topic in our SS2 physics series. This topic appears regularly in your examinations. Pay close attention. Let us begin. First, let me explain what a wave is. A wave is a disturbance that travels through a medium. It transfers energy from one point to another. It does not transfer matter. The particles of the medium oscillate. They do not travel with the wave. Waves are everywhere in nature. Examples include sound waves, light waves, and water waves. Understanding waves is essential for understanding many physical phenomena. It is essential for understanding sound, light, and communication. Waves are fundamental to physics. They are essential for understanding how energy travels through the universe. Now, let me explain the types of waves. There are two main types of waves: mechanical waves and electromagnetic waves. Mechanical waves require a medium to travel. They cannot travel through a vacuum. Examples include sound waves and water waves. Electromagnetic waves do not require a medium. They can travel through a vacuum. Examples include light waves and radio waves. There are also two types of wave motion: transverse waves and longitudinal waves. Transverse waves have oscillations perpendicular to the direction of propagation. Examples include light waves and waves on a string. Longitudinal waves have oscillations parallel to the direction of propagation. Examples include sound waves. Understanding the types of waves is essential for understanding wave phenomena. Each type of wave behaves differently and has different applications. Now let me explain the properties of waves. Waves have several properties. The first property is wavelength. Wavelength is the distance between two consecutive points in phase. It is measured in meters. The symbol for wavelength is lambda. The second property is frequency. Frequency is the number of waves passing a point per second. It is measured in hertz. The symbol for frequency is F. The third property is period. Period is the time for one complete wave. It is measured in seconds. The symbol for period is T. The fourth property is amplitude. Amplitude is the maximum displacement from the equilibrium position. It is measured in meters. The fifth property is speed. Speed is the distance traveled per unit time. It is measured in meters per second. Understanding these properties is essential for understanding wave behavior. Each property describes a different aspect of the wave. Now, let me explain the wave equation. The wave equation relates speed, frequency, and wavelength. The formula is V equals F times lambda. V is speed, F is frequency, but lambda is wavelength. This equation applies to all waves. It is one of the most important equations in physics. Understanding the wave equation is essential for solving wave problems. You must be able to use this equation to find any of the three quantities if the other two are known. For example, if you know the frequency and wavelength, you can find the speed. If you know the speed and frequency, you can find the wavelength. Now, let me explain wave propagation. Wave propagation is the movement of waves through a medium. The particles of the medium oscillate. They transfer energy to neighboring particles. The wave travels through the medium. The speed of the wave depends on the medium. It depends on the properties of the medium. For example, sound travels faster in solids than in gases. Sound travels faster in water than in air. Light travels slower in glass than in air. Understanding wave propagation is essential for understanding wave behavior. The medium affects how the wave travels. Now let me explain reflection of waves. Reflection is the bouncing of waves off a surface. It occurs when a wave strikes a boundary. The wave is reflected back. The angle of incidence equals the angle of reflection. This is the law of reflection. Reflection occurs for all types of waves. Examples include sound echo and light reflection. Echo is the reflection of sound. Mirrors use reflection of light. Understanding reflection is essential for understanding wave behavior. Reflection is used in many applications. Now let me explain refraction of waves. Refraction is the bending of waves as they pass from one medium to another. It occurs because the speed of the wave changes. When a wave enters a denser medium, it slows down. It bends towards the normal. When a wave enters a less dense medium, it speeds up. It bends away from the normal. Refraction occurs for all types of waves. Examples include light refraction and sound refraction. Lenses use refraction. Prisms use refraction. Understanding refraction is essential for understanding wave behavior. Refraction is used in many optical instruments. Now, let me explain diffraction of waves. Diffraction is the spreading of waves as they pass through an opening or around an obstacle. It occurs when the wavelength is comparable to the size of the opening. Diffraction is more pronounced for longer wavelengths. Sound waves diffract more than light waves. This is why you can hear sound around corners. Diffraction occurs for all types of waves. Understanding diffraction is essential for understanding wave behavior. Diffraction is used in many applications. Now let me explain interference of waves. Interference is the superposition of two or more waves. When waves overlap, they interfere. There are two types of interference: constructive interference and destructive interference. Constructive interference occurs when waves are in phase. The amplitudes add. The resultant amplitude is larger. Destructive interference occurs when waves are out of phase. The amplitudes subtract. The resultant amplitude is smaller. Interference occurs for all types of waves. Examples include light interference and sound interference. Understanding interference is essential for understanding wave behavior. Interference is used in many applications. Now, let me explain the principle of superposition. The principle of superposition states that when two or more waves overlap, the resultant displacement is the sum of the individual displacements. This applies to all waves. It is a fundamental principle of wave behavior. Understanding the principle of superposition is essential for understanding interference. It is essential for understanding standing waves. The principle of superposition explains many wave phenomena. Now let me explain standing waves. Standing waves are waves that appear to be stationary. They are formed by the interference of two waves traveling in opposite directions. They have nodes and antinodes. Nodes are points of zero displacement. Antinodes are points of maximum displacement. Standing waves occur in strings and pipes. They are used in musical instruments. Examples include guitar strings and organ pipes. Understanding standing waves is essential for understanding acoustics. Now let me explain the applications of waves. Waves have many applications. In communication, waves are used for transmission. Radio waves, microwaves, and light waves are used. In medicine, waves are used for imaging. Ultrasound and X-rays are used. In music, waves are used for sound. Musical instruments produce sound waves. In technology, waves are used for sensing. Radar and sonar use waves. Understanding the applications of waves is essential for understanding modern technology. Now, let me explain the importance of waves. Waves are important for several reasons. First, they transfer energy. They allow energy to be transported. Second, they allow communication. Waves are used for transmitting information. Third, they allow sensing. Waves are used for detecting objects. Fourth, they allow imaging. Waves are used for medical and scientific imaging. Fifth, they allow music and sound. Waves are essential for hearing and music. Understanding waves is essential for physics and technology. Now let me give you sample exam questions. Define a wave. A wave is a disturbance that travels through a medium, transferring energy without transferring matter. State the types of waves: mechanical waves and electromagnetic waves, transverse waves, and longitudinal waves. State the wave equation: V equals F times lambda. Explain reflection of waves. Reflection is the bouncing of waves off a surface. Explain refraction of waves. Refraction is the bending of waves as they pass from one medium to another. Explain interference of waves. Interference is the superposition of two or more waves. Let me summarize. A wave is a disturbance that transfers energy. There are two main types: mechanical waves and electromagnetic waves. There are two types of wave motion: transverse and longitudinal. The properties of waves include wavelength, frequency, period, amplitude, and speed. The wave equation is V equals F times lambda. Waves reflect, refract, diffract, and interfere. The principle of superposition applies to all waves. Standing waves have nodes and antinodes. Waves have many applications. Understanding waves is essential for physics and technology. This completes our SS2 physics series. Well done.